of thermodynamics. So in thermodynamics, three laws are defined. First one is zeroth law. Second is first law, and next is second law. So these are three laws in thermodynamics. Now, why zero is there here? Why not first, second and third? If you see this, which are laws of kinematics, those laws are Newton's first law, second law, third law. So these are the laws in kinematics. Here in thermodynamics, instead of first, second and third, why it is 0, 1 and 2? Why? Okay. I will discuss on this. Actually, in thermodynamics, first law invented. The first law came. After first law, second law invented. Okay. Next is zeroth law. A law invented actually, that is not zero. After the second one, a law invented. So a name has to given for this one. Actually it has to get a name of third law. So why given 0 for this one is, 0 means like this 0. Instead of 0, they are writing ZERO. Instead of 0, they are writing ZERO here. Instead of number 0, they are writing 0. ZERO. So when they invented this, which one? Zeroth law, here one of the important parameter which defines this 0 law, that important parameter is there in first and second law. So because of the importance of parameters, this not parameter, because of that important parameter, it has to go up above that first law. So above first law means this already number 1 is given here. So before number 1, number is 0. So that's why this law has given a number 0 here. The law given a number 0, like this 0 number, 0 law. So instead of that 0, they are writing ZERO, zeroth law. Okay. So that's why in thermodynamics, we have three laws. First one is zeroth law, zeroth law. Next is first law. Third is second law. Right? Now we'll discuss what is zeroth law and what is the importance of this law and what is the important parameter which is there in this law. Okay. So before going detail into this zeroth law of thermodynamics, first we have to know the equilibrium condition. What is equilibrium condition? Equilibrium. Right? What is equilibrium condition? Here in thermodynamics, actually we will study the important factor of this one, heat. Heat means the temperature or temperature thermal. Whenever this hardness means thermal, this word thermal will come into this which one concept here. So instead of this equilibrium means when forces are equal, we can say that is an equilibrium condition. But here we are not dealing the forces, we are dealing the temperature here. So thermal equilibrium. So that's why the word which one thermal we have to use before this equilibrium. So in this zeroth law, we'll use this condition, thermal equilibrium. What is thermal equilibrium? When temperatures are equal. When temperatures are equal. When temperature when temperatures are equal, for any two systems, for any two systems, okay, then we can say those two systems are in thermal equilibrium condition, right? So thermal equilibrium means temperature should be equal. So that is the basic behind this zeroth law. So to define this zeroth law, here now I can say here we have used the thermal equilibrium condition. The thermal word we used here, right? Thermal word we are using here. Thermal means temperature. Temperature. Okay. So this is the important parameter in zeroth law of thermodynamics, right? So zeroth law of thermodynamics defines the temperature. So that is the important point here, right? Now we'll define this zeroth law. So here to define this zeroth law, first you have to consider two systems here, A and B, like this. I am considering A and B, two systems here, and two more systems here, A and C, right? So here temperature of TA is greater than temperature of TB. Here temperature of TA is greater than temperature of TC. So when the temperature is greater than here, heat will flow like this, from higher temperature to lower temperature. That is nature. Here also temperature of A greater means here it will flow like this, from higher to lower. So heat flows like this until these values are equal. Means these temperature values are equal, then we can say the condition, what are the condition we discussed, means TA equal to TB, here TA equal to TC, then transfer of that heat will stop here in these two conditions. Then we can say this condition is reached, thermal equilibrium. Equilibrium condition is reached. Condition is reached. Okay. Condition is reached. Right? Thermal equilibrium condition is reached. Now, the zeroth law states that whenever A is in thermal equilibrium with B, and whenever this A is thermal equilibrium with C, this A is common here. When A with B and when A with C, then B is C, means B is in thermal equilibrium with C. So that is our zeroth law of thermodynamics. Okay. And actually this is law here. Law means always this condition is not true. Always this condition is not true. Suppose if you take in max x equal to y, right, and x equal to z, this implies y equal to z. This is true in mathematics. But in this condition, this mathematics can't apply here, because when E is in B, A is in C, when temperatures are equal, then B temperature is equal to C is not always true. Here scientists done experiments, and for this condition they told, that is that zeroth law which we are defining, they told that B is in thermal equilibrium with the C, right? So that's why this is known as law. Law means experiment conducted and defined here. So a law is given. Law means authority is given for this one. So this B is in thermal equilibrium with the C. Not because of this condition, not because of the mathematics condition, this is law here. Okay. Now again I am summarizing here what is the zeroth law. So to define this zeroth law, we have to know the first one is what is thermal equilibrium. Okay. We know that thermal equilibrium is when temperatures are equal. Okay. So this condition we have to know, right? And one parameter which defines the zeroth law, important parameter in zeroth law is temperature. Okay. So because of these two, we defined zeroth law. What is the zeroth law? Consider three systems A, B, C. If A is in thermal equilibrium with B, right, and A is in thermal equilibrium with C, then we can say B is in thermal equilibrium with C. So this is zeroth law of thermodynamics. Okay, thank you.